Hey everyone, how's it going? Brian here with another Java game programming tutorial. So the last time we left off, we did some work on our abstract classes and our tower types here. We made our little tower type enum right here. And we created a cannon red and a cannon blue. But as you can see in our game, they actually have regressed in the sense that they cannot sense the enemies or shoot or track them. And so we're going to change that this episode. And the way we're going to do that is we're not going to bother reinventing the wheel. We are simply going to take the code that we've written from our cannon tower class, or our tower cannon class, and we're going to implement it into our tower abstract class. So let's just go ahead and go down the line. We're going to go one method at a time to make sure we don't break anything, and to make sure that everything is all super kosher here. One thing we could do from the start is I see we have a range here, which we have not implemented yet. So we should go to our tower types and make that another variable that we track. Range. And range. And now we haven't actually gotten around to implementing our range methods yet, as in like detecting when an enemy is in range and out of range and transferring that way. So far our towers only transfer to a new target by killing their original target or when the target dies. So for now we're just going to set the range to something that we don't have to worry about. So we'll just say 1,000 is our range. So go ahead and put 1,000 for both of these. But at least now we have it set up so that range is in our tower type class, so that when we work on our range detection we can easily pass that data through these tower types right here. Now back to our tower cannon class. We will just start going method by method. So the first one will be acquire target. Just go ahead and copy this right here. The actual tower cannon class, when we're done doing this, will probably be deleted. If not, it'll be heavily modified because it'll be extending our tower class. So yeah, just go ahead and copy this acquire target method. And let's go ahead and put it... You know, I actually want to copy our update and our draw, copy those and delete them from where they are at in our tower class and put them above our getters and setters. I like having the getters and setters at the very bottom of the class. Just a preference, but it'll help you stay organized, I think. And now let's go back to our tower cannon class and copy the acquire target method and go ahead and put it above our update method in our tower class. Now you'll see right away we have a lot of errors because we're missing all of the variables and methods that's calling for. So one that we can get in here, or two actually, is a list of enemies and a boolean for whether or not our tower is targeted, as in it has a target. So we'll go ahead and add those here. Private array list, enemy, and name it enemies, and a private boolean for targeted. You'll need to import the array list class here. And we should set these up down here. Say this dot enemies. For right now, we're just going to say equals a new array list, even though we will be changing that in this video. Equals new array list of type enemy. And this dot targeted starts as false. We do not have a target when we first start our tower cannon. And these are methods that we need to implement next. So let's go back to our tower cannon class and get is in range. And you know, some of these methods, such as find distance and is in range, we might actually move to a new helper class I've been thinking about that does like some of this math for us. Because, you know, find distance isn't really something that we just need for our towers. You know, it might come in handy later when deciding, you know, who knows what. Finding the distance between two objects is something that we should probably have in a helper class that we can use in various other classes. But for now, we're just going to hold it in our tower class because our tower is the only thing that's using it so far. But for now, is in range, copy that. And we'll put it right below our acquire target method. And here's where our range comes into play. So let's make a variable for our range. We'll make it an integer. Range. And we can get that right here after our damage. This dot range equals type dot range. Because remember, we added the range variable to our tower type enum. Now let's go back and get find distance from the tower cannon. And as I said, we're going to have that in here for now. Put it below is in range. I guess, the order doesn't really matter, but I'm just trying to keep it in a way that makes sense for me. We don't need to change anything with this, so we're good there. Let's get calculate angle, which is another thing that we can move to a helper class, but for now we'll put it in our tower abstract class. Calculate angle. Shoot is something that I'm a little hesitant to put in our abstract class, but I guess the way we're doing it is this will just be our tower abstract class. These methods are meant to be overloaded or overwritten. So this is just the default shoot method, right? Not too exciting, just if you have a target, shoot it, and then wait for, you to be ready to shoot again, that little cooldown period. So we're gonna add this to our abstract class, but don't worry because we're gonna be overwriting this method in all of our little sub towers. So if we have AoE or rockets or whatever, this is just our main default shoot method. So put that in there. We're gonna need to add a list of projectiles as well as a float for the time since the last shot to calculate how fast we're shooting our enemies. So at the top here, go ahead and add a time since last shot variable and an array list of type projectile named projectiles. And we can initialize those down here. This dot time since last shot equals 0f. This dot projectiles equals new array list, of type projectile. Update enemy list, this is an easy one, we can add that. Put it right down here. And our update method. And we can just copy this entire update method as it is and replace the one currently in our tower class, which is empty. There we go. Firing speed, that is something that we can add in our tower enum. In fact, we'll do that right now. I feel like that should probably be a float. So float firing speed, and we'll add that in the constructor. And I believe we're doing it in seconds. So for now, we'll just put it at 3, which I believe is what our tower cannon was already at. Have a firing speed of 3. And we can set that in here by making a firing speed float. And then setting that via the type as so. This dot firing speed equals type dot firing speed. And our last error is we don't have an angle. And that's easy. We can just make a float for our angle that we're going to draw our cannon at. Angle. And we'll set it at 0 to start off. 0f. Okay, so we have no errors, but it's a little misleading because if we ran it right now, we would crash the game. So let's go ahead and try that real quick and we can see the error that we get. It's a null pointer exception, and the reason we're getting that exception is because our enemy list, as I said when we started to implement it right here, enemies, we're meant to pass in the enemies from somewhere else, right? We can't just say, here's a blank list that is supposed to hold enemies, and you can just, choose what you fire at because they don't exist. We need to get the enemies from either the game, or the player, or the wave manager. So we'll do it the same way we did with our tower cannon class, and that is via the player. The player is the one that's making the towers, so that's a good time for us to pass in an original enemy list from our wave manager, which is also made by the player. And we could also update it using that update, I believe it's just called update enemy list in our tower class. So let's go in our player class, and yeah, in fact it is, update enemy list. And we can uncomment this now because it exists in our tower class, so that takes care of that. But we should also pass in enemies to start off with in our tower constructor. So let's go ahead and, in addition to our type and start tile, let's also take an array list of type enemy named enemies. And now we can set this dot enemies equal to enemies. Now we'll need to update the constructor over here in our player class to take new tower cannon blue. Oh, we need to update the tower cannon blue constructor to reflect that change. So new array list of type enemy, named enemies, and just pass in enemies. There we go. Oh, make sure you import this. Now in our player class, let's save that. In our player class, we can add the enemies right after this parenthesis. So there's 2 more parentheses after this. Put a comma, wave manager dot get current wave dot get enemy list. And if you recall from a few episodes back, this is the kind of method chain that we implemented to get the current enemies on the screen and update our towers with that information. We're going to change the way we do that in the future, probably in our optimization episode, because this could be a little bit cleaner. But for now, we're just trying to get it to work with our different tower types. So now that our tower can see the enemies, let's see if we still get that error or not. Run the game, and we don't get an error, and will they fire? They do. Now, of course, you can see that the towers aren't actually tracking the enemy. Well, really they are, because they're firing towards them, but it's not showing that tracking, as in the little turret, the cannon on top is not spinning. And can you guess why that is? The answer is in our draw method. So we actually are calculating our angle correct, but we're not drawing a rotated texture. Where's our draw? Here it is. So our draw method is a little bit interesting, because remember, the point of this tower abstract class is to make it as, what's the word? To make it as accessible or as neutral as possible, so that all of our different tower types can kind of inherit as much as possible from this without having to rewrite any code. The draw method is a little bit interesting, as in we'll probably want to draw a lot of different towers in a lot of different ways. Some of them might only be a couple textures and maybe like the bottom rotates but the top is like a floating orb. You know, some of them might have like moving parts and arms and all that stuff. So the draw method is something that might get commonly overridden. But for now, we're going to set it up so that it works with our, basic towers, which are our cannon red and cannon blue towers. So far what we're doing is we're passing in an array of textures, so a number of textures all under one variable named textures. And what we're doing currently in our draw method is we're going through every texture and we're just drawing it at the X and Y width and height. But if you recall in our artist class, we have an entire different method for drawing rotatable textures. Draw quad text rotate, or ROT. So what we're going to do is, let's copy this right here and paste it up there. And instead of I, because that doesn't exist up here, just say 0. So that's the first texture in our array, which would be the base always, because the way we set it up, the bottom texture is first, and then it kind of layers on top of that like a cake. So we're going to draw the base regularly, and then we're going to say if textures, which is our array of textures, dot length is greater than 1, and we're going to go ahead and highlight this and kind of tab it over to indent it. So if we have more than one texture for the tower, which we almost always should, we're going to change this from 0 to 1 because we're starting with the second texture, which is texture number 1 after 0. We're going to draw these as rotatable textures, and we're going to include the angle that we've calculated right there. Now this is going to be an error probably for you because we need to import the draw quad text rotate method. So up here, right after our draw quad text, we can just import draw quad text rotate, and that should take care of that. So what we're saying in our draw method now is draw the base normally, don't rotate it, and then every texture on top of that we're going to rotate. So, obviously this is I don't want to say temporary because it's not temporary, but it's a very specific case that this works for, which is our cannon red and cannon blue, where we have one base and then one cannon on top. This is something that will be overridden in our specific tower subclasses, such as tower cannon blue. Obviously not that tower specifically, but that kind of subclass. But let's go ahead and try the game out and see if this works now. And it does. So now we have fully functioning towers that are inheriting from our tower abstract class. It might not look incredible because we already had something similar on the screen, 5 or so episodes ago. But what's really cool now is that all of our towers are inheriting or extending the same abstract tower class. So you can see here we have them all in a list called tower list, which is a list of all of our towers. We'll easily be able to create new types of towers and add them to this list. And they also all follow the same set of rules, which is, if you remember, our rules for our entity interface. So we can call the same methods and variables on all of our different towers and all of our different drawn entities, such as enemies and tiles, etc., etc. So even though the game doesn't look that different, we've really done a lot of behind-the-scenes work to make sure that it's easily extendable. And just for funsies, we can actually, let's go ahead and copy this here in the player class where we left-click to make a tower. I'm going to copy it and put it right down here. But instead of the left mouse button, change this to 1 to make it the right. And instead of cannon blue, we'll make it cannon red. And we also need to make a boolean for, this is something we're going to do anyways, is make a boolean for the right mouse button as well. So right mouse button down. Go ahead and set that right here. This dot right mouse button down equals false, because it's probably not down. And then right here after the left one, just say right mouse button down equals mouse dot is button down 1. So now we can track our left and right mouse buttons. Had we not done this, then this if statement still would have worked, but if you recall, the problem we had last time is that it updates as a click every single time the game updates. So if you right click on the screen, it might count as like, 7 or 13 or 30 clicks. This way we're only doing it once per click. We're only doing our action one time per click. Now if we run the game, we can easily enjoy 2 different tower... Oh! Alright, so it actually... wow, it looks pretty cool actually. So we didn't update it correctly because we're still getting all those clicks every time we right click. That looks kind of sweet though. It gives me an idea for a tower type where we almost have like a lightning kind of thing. Let's see what we did wrong here though. We have right mouse button down, number 1, left 0. Oh, here we go. We're not checking if the right mouse button is down here. We're checking if the left one is. I think I said that right. So just change this from left to right, and that should fix that issue. There we go. Now we're getting 1 tower per click. And we can enjoy having 2 different looking towers on our screen. They are still, obviously very similar. But what we're going to do is probably next time work on changing them a little bit. Maybe giving them each a different custom projectile that might go faster or slower, or have more or less damage and have a different color than the other towers. And after that, we probably will make an entire new kind of tower, whether it be a rocket tower or laser or something different from our little cannon tower that we've been kind of experimenting with and creating like a base tower class around. Anyway, that's all for this time, so thank you for watching. Make sure to check out the Patreon page at patreon.com/indieprogrammer, and I'll see you next week for another episode of Java Game Programming.